Question 98, validate binary search tree. Giving the root of a binary search tree, determine if it is a valid binary search tree. And what is a valid binary search tree? A valid binary search tree is the left subtree, the nodes that we have is smaller than root and root is bigger than right. So let's see this example. In this example, this is a valid binary search tree because 1 is smaller than 2 and 2 is smaller than 3. How about this one? 1 is smaller than 5 and 5 is not smaller than 4. So this is not a valid binary search tree. So what we are going to do here, we are going to traverse a tree and compare the left node, and if the left node is valid and right node is valid, then we are going to return true. For doing that, we are going to say if not root, if there is no node, we are going to return true. And if the root node.val is smaller than or equal to the left node, the left value that we have, we are going to consider a left value of minus infinite and a right value of positive infinite for the root node. And as we go through as we traverse the tree, we are going to update the left value and right value. These left and right variables, they weren't in the body of the code, but I have added these two variables. So we are going to use minus infinite and positive infinite as the default values, and as we traverse the tree, we are going to update these two. So now what we are going to do, we are going to say if the root value that I have, which is 2 here, is smaller than left, or if the root value that I have is bigger than or equal to right, then I'm going to return false, right? So if 2 is smaller than minus infinite or 2 is bigger than positive infinite, we are going to return false, which is not. And then I'm going to return these function recursively for the left and right node, because I need to make sure this the left node is smaller than root and root is bigger than right. So I need to call it twice. So and one time for the left node and one time for the right node. So I'm going to say root dot left, and now I need to check with the left value that we have, which there is nothing there, so it's gonna be the default value that we have, and the right value, which is going to be the root dot val. And then this is for the left node. I need to do the same thing for the right node. Is valid, so I'm going to say right, and for the right value I have nothing, so I'm going to say root.val for the left value and for right like this. And then as we iterate over the tree, these left and right values are going to be updated. So when you want to code this validate binary search tree, you better to use a simple case, and when you write your code, it's going to be applicable to bigger trees as well. So let's run this code and see how it works. There you go, it works perfectly. So as we are going to use recursive functions, it's going to be linear space complexity, and as we are traversing the whole tree, it's going to be linear time complexity as well. So let's go through an example so you can better understand the code. Let's say this is the binary search tree that we have. You can see the example here, right? This is 5, 1, 4, 3, 6, right? We start with 5. The default value for left is minus infinite. The default value for right is positive infinite. We call it for this function to begin with, and the root is not empty, and 5 is not smaller than minus infinite, and 5 is not bigger than minus infinite. So we are going to return these two functions, recursively call this function for the left node and right node. For the left node is going to be 1 and left is minus infinite, and the right is going to be root.val, which is going to be 5. And for the right is going to be root.right, which is going to be 4, and root.val, it's 5, and right, which is positive infinite. This is two functions that we call. And then we need to call this function for the left node and right node. As the left node and right node, they are both none, we are going to return for these two, and true and true is going to be true, right? And then for this one, when we call the function for this, the root.val 4 is smaller than 5, and if it is smaller than 5, we are going to return false. So this is going to be false. True and false are going to be false. So for this example, we are going to return false. But instead of 4, if we had 7 here, the case was valid and we were going to return true, like the example that we have here. We call it for the left node, which is 1, and I replaced this 4 with 7 to make this valid binary search tree. So we call it for 1 and for 7. This doesn't have any child, it's going to be non, and this one has 3 and 6, and the whole tree is going to be true, and it's a valid binary search tree. Thank you.